So in this video, I'm going to talk about key characteristics of linear functions again and just go through one full example of some of those key characteristics. So, just as a reminder, some of those important characteristics are their x and y intercepts, the domain and range, intervals where they increase and decrease, intervals where the graph is positive or above the x-axis, and negative below the x-axis, and then the end behavior, just what's happening at the ends of the graph. So to do one full example here, if I want to state the key characteristics of this function, f of x equals 2x minus 1, that's a line, a linear function, it might be helpful to graph it. You can do this in your calculator or on Desmos, or just by hand. It doesn't take very long to graph this by hand. It's got a y-intercept of -1, so we'll start here, and it has a slope of 2, so 2 over 1, rise 2 over 1, rise 2 over 1, and so on. And so there is my line. It should have arrows on the end because it does continue forever. It doesn't stop, it's not a line segment. And so I'm going to state some of those key characteristics for this graph. First thing would be the x-intercept and the y-intercept. The y-intercept is pretty clear, it's just -1 right there. To find the x-intercept, you can kind of see on the graph how since I'm going up 2 over 1, that's pretty much the same as like up 1 over a half. So the x-intercept here is actually 0.5 or 1/2. You may want to write this as a full coordinate, or you can just write the number as it is. So like you could have put like 1/2, 0 as a full point. Same thing with the y-intercept, you could have put 0, -1. Either of those are fine. Just as a reminder, if you wanted to use the equation to solve for the x-intercept, that happens when y is 0. So if I substitute in 0 for y, I could solve for that x-intercept by adding 1 to both sides and then dividing by 2, and you see that's how I get 1/2 as well. All right, for the domain and the range, that's what we'll do next. Remember, the domain is all the possible x values, all the input values. And think about the points on this graph. This graph has 1, 1, and 2, 3, and 3, 5. It's even got like 1.5, and it's got an output there. And even like 1.1 has an output. And same thing in the negative direction. I could go -6 and I would have an output. I could go to -5,000 and I would have an output. So regardless of where I am on the x-axis, I always have an output. So the domain is actually everything. The domain is all the numbers. And the way we usually say this is all real numbers, because it doesn't include imaginary, but it does include rational and irrational numbers, all the decimals. It's all real numbers are in the domain. Another way of writing this is a big R with like a line through it. This stands for all real numbers, so those mean the same thing. Or you could even say it's an interval from -infinity to infinity. All three of these things mean the same thing. They just mean every possible numbers in the domain from -infinity to infinity. There's no point at which the graph stops. If the graph did stop, the domain would look different. Like let's say this was an endpoint and this was an endpoint. In that case, the domain would only be from -1 to 3, and the range in that case would be from -3 to 5. But that's not the case here, because there's arrows on the end. It continues. So the domain is it goes left and right forever. The range is actually the same. The range is the y values, but it goes up forever and down forever. So the range is also all real numbers, or we could say -infinity to infinity. Next, let's talk about, is this graph increasing or is it decreasing? And it's a line, so it's going to be doing one of those two things, unless it's just flat. This line has a positive slope. Think about if you were traveling along this line from left to right and you were on like a bike or something, that'd be a pretty steep slope you're going up. So this graph is increasing rather than decreasing, and that's because it has a positive slope. Next thing we'll talk about is the interval where the graph is positive. And also the interval where it's negative. Okay, remember, it's positive when it has a positive output, and it's negative when it has a negative output. I like to think of this as like above ground and below ground, like above sea level, below sea level. Or even like with my stocks, it would be like, are you in the green or in the red kind of thing. So the graph is positive above this line, and it's negative below the x-axis. So it's positive from here on. Remember, when we talk about these intervals, we always use the x values, not the y values, to describe that interval. So I'm going to say that it goes from 1/2 on to infinity. That's where it's positive. So from 1/2 to infinity. And it's negative from here over, basically. So from 1/2 to negative infinity, although we usually put the smaller value first. So I would call this from negative infinity up until 1/2. It's negative, it's below the x-axis. Technically we do parentheses around the 1/2 because the 1/2 is not included. It's right in between positive and negative, but that's okay. Remember, you could also, if you wanted to, write this in set notation rather than interval notation. So instead of saying from 1/2 to infinity, I could have just said where x is greater than 1/2. And instead of saying from negative infinity up until 1/2, I could have just said where x is less than 1/2. These mean the same thing. So whichever you prefer, although I would recommend the interval notation just so you get used to that. All right, the very last key characteristic that we're going to talk about, at least, is the end behavior. I'm going to erase this. Oops, lost my line. Looked like this. Okay, the end behavior is literally just what happens at the ends of the graph. So like, what's happening right here and what's happening over here. On this end, it's going up. On this end, it's going down. To say that in slightly more mathy terms, we might say the y values are increasing and the y values are decreasing. Or the y values are approaching infinity and the y values are approaching negative infinity. Also, a mathier way to say the right side of the graph would be as x approaches infinity. Remember, this just means as we go this way, what's happening? Since the graph is going up, I'll say y is approaching positive infinity because it's going up. For the other end over here, to start this one off, I'll say as x approaches negative infinity, because as we go that way, we're looking at this end of the graph. In this case, it's going down, so y, the output, is approaching negative infinity. Instead of y, you might have used f of x, or you could even write out the word approaching, or you could have said as x increases, y increases, and as x decreases, y decreases, anything like that. So that is the end behavior, and those are just a few of the key characteristics of this particular line.